Welcome to the University of Wisconsin-Madison. This is the engineering campus. Right behind me you'll see Engineering Hall, and out that way you see the world-famous Camp Randall, home of the Badgers.
Alright, welcome to the UW Makerspace. Here's one of our rapid prototyping facilities on campus. In this area we have a bunch of 3D printers, a couple laser cutters, and very small hand tools that you can use to make whatever your team needs. For us, it's going to be our drone. This is where we are 3D printing most of our parts.
Welcome to the fourth floor of Went Commons. This is one of the active learning spaces here on campus that we're really proud of. Every mechanical engineer knows this space all too well as the place that they likely had statics discussions or dynamics discussions growing up. It's perfect for things like that. It's a large, wide open space with a bunch of these little pods. Now, each of these pods has 4 computers around it, 3 in the times of COVID, and there so that students can go ahead and collaborate while social distancing and working on the same thing. As you can see, there are TV screens all up in the corners, and each team can project whatever they're working on to these TVs so that TAs and professors can easily see them.
Alright, so my first favorite part on top here is the W, which provides adequate cooling and protection of the electronics in case of a crash. And it also has W for Wisconsin. Down in the arms here we have we have 2 vertical rib stiffeners. One of the big issues of printing with PLA is the fact that it is very much not rigid, and we were having issues with our control system. So then I added those in there to stiffen things up. And then under here there's a battery holder. This battery holder is actually bolted on to allow us for quick prototyping of this arm. So we'd only need to change this part instead of the entire frame when we're trying different arm systems. The current arm uses 4 magnets and a bunch of sweepers to get the magnets to attach onto the top of the payload.
Hello, my name is John, and welcome to John's Table of Fun, or Broken Stuff. This is a bunch of the parts that we had that ended up failing. An important part of our design process was iterative design. We actually started out doing these PLA prints with the end goal of producing a final part that was to be carbon fiber and a fiberglass composite. But that ended up being 10 times more expensive than these PLA prints. So one of our iterative design things is we decided to stick with this PLA stuff. Another thing that was really interesting is we noticed that our drone arms were going to be by far the most susceptible thing to breaking. And so this is one of the pieces that we had tried out, and initially, as you can see right here, there's a nice fillet right at this point. But initially we had a nice square corner, and that ended up cracking a lot of these pieces. So implementing this fillet was really important to us in reducing stress concentrations. Another thing that we did along the way that we thought was pretty neat is we integrated this battery holder into the control arm for grabbing the block and the payload. But that ended up being a bad idea because whenever we broke an armature, which was fairly often, we would have to replace both the battery holder and the armature. So splitting those 2 things up into separate pieces, as you can see right here, we've got 2 separate pieces. That was really important to making sure that we were maximizing our efficiency and utilizing our parts to the best of our abilities. We're the UW-Madison ASME design team. Thank you so much for watching our video. All further details can be found in our design report. Thank you so much for watching our videos. We hope you enjoyed it as much as we enjoyed making the drone for this competition.